Welcome to Brain Vision.
In this problem on the topic of magnetic field and magnetic forces, we are given the internal resistance of a DC motor with its rotor and field coils connected in series. We know the voltage when the motor is running at full load to be 120 volts and the EMF to be 105 volts. We want to find the current that is drawn by the motor from the line, the power that is delivered to the motor, as well as the mechanical power that the motor develops. Now, we know firstly that the potential difference across AB, VAB, is given to be 120 volts. The EMF for the motor is 105 volts, and the internal resistance, little r, is equal to 3.2 ohms. So firstly, in part A, we want to find the current that is drawn by the motor from the line. So the potential difference VAB is equal to the EMF epsilon plus the potential difference across this internal resistance I little r, which means we can rearrange this equation and solve for the current. And we get the current I is equal to VAB minus epsilon over the internal resistance R. And so if we substitute our values in, this is 120 volts minus 105 volts divided by the internal resistance of 3.2 ohms. And so calculating, we get the current to be 4.7 amperes. Next, for part B, we want to know the power that is delivered to the motor. So we'll call the supplied power P subscript supplied, and this is equal to the current I times the potential difference VAB. So that's the power that's being supplied to the motor, and that's 4.7 amperes times the potential difference of 120 volts, which gives us the supplied power to be 564 watts. Now that we have the power that is being supplied to the motor, we want to know the mechanical power that the motor develops. So that's different from the power that is supplied to the motor. So the mechanical power we'll call P subscript mech, and this is I times VAB minus I squared R. And so this is equal to 564 watts as calculated above, minus 4.7 amperes squared times the internal resistance of 3.2 ohms. And so calculating, we get the power that is delivered by developed by the motor rather, to be 493 watts.